Hi. So in the last video, we saw how the distribution was affected with the help with these stop words, because the stop words were the majority. The stop words were contributing in majority, and we want to kind of remove the stop words because these stop words do not convey any kind of meaning to us. So we will be using NLTK for this. So basically, over here, if we are having this, we have to download the kind of stop words first. So first what we'll do is we'll use this nltk.download stop words. So basically what will happen is we have to download a set of stop words first in order to pre-process the task. So what I will do is I will just type in over here, and I will type in download, and I will press shift tab over here, and you can see the download directory over here, right? So this is the option which I will be selecting. So download directory would be my home directory or the directory in which I am working. So if I just write dot and write slash, I'll get all the files which are present in the current working directory. So I want to download all the stop words in this directory only. So for that I have to mention the download directory specifically. Now if I shift enter this, it will download all that, and I will just show you how it will look like. So over here what it showed, over here it displayed that, over here it displayed stop words, and download directory is this, right? So this is the corpora, and over here we are having the stop words, and over here we are having stop words for every single language which is present. Like not every single language, for many languages we are having the stop words. Like for English, if we want to see the stop words, we can click on this and edit as notepad, and we can see the stop word over here. Just it will take a little bit time because there are many stop words which are present in back of the scenes. So over here we are having this stop words. There are almost like 180 stop words which are present. So for every language you can see the stop words, right? So we will be downloading those stop words, and then after that we will be using this corpus from NLTK corpus. That was this corpus over here, this corpora, so they were the corpus. So from NLTK corpus input stop words, and then stop words dot words of English. So basically it will go inside that file, and it will gather all the stop words into this set. Now why we are using set? Because there may be some stop words which are repeating. So we want to remove the duplicated stop words. We want all unique stop words only. So that's the reason why we are using the set. Okay. So all the stop words set is mentioned over here. Now we will be removing the stop words. We will define a function to remove the stop words. So what this is doing is, this text is a huge chunk of example, this will be a kind of text which will be passed to this function. So in this function what we need to do is we need to separate them word by word, right? So we need to separate them word by word, means we will do word for word in text dot split if word not in stop words. So that means, what is the thing? Text dot split means basically it will split the text into words, and for every word we will check whether that word is present in the stop word or not. If the word is not present in the stop word, then only we will use that word, right? Otherwise we will not use the word. So basically this is a kind of removing all the stop words. So that is why it is named as removed stop word. After that we will join the all the words to make a sentence using this join function, so that all the stop words will be removed. Now we will be applying this, we will be using a lambda function for applying this, right? So books of summary is equals to books of summary dot apply lambda x remove stop word of x. This means that for every, this lambda x means for every summary in books of summary, you apply remove stop words of x function. Remove stop words of x function. So this will basically return me a sentence which will have all the stop words removed. Now books of summary dot dialog of 1, just in order to check whether it is working fine or not. Yeah, we can see over here all the stop words were removed because the length of the sentence has been reduced. Over here the length of the sentence was huge enough, but over here the length of the sentence is comparatively less. So that means all the stop words have been successfully removed. So we'll be using this method to remove all the stop words. Now the next process is we'll be using this lemmatizing thing. So basically lemmatizing is nothing but it's a kind of giving a priority to some synonyms, antonyms or similar kind of words. So we will be using the NLTK library for downloading the WordNet over here as well. So if I just press download dir over here, download dir and this if I keep, it will download the NLTK, it will download the WordNet zip file into the existing working directory of mine. So if I just go over here and go to Corpora, I can see that I get this WordNet over here. So if I just go and check at the WordNet, I'll be looking at so many things over here. So data.web, index.web, noun.exe, lex names, adjectives, and nouns, everything will be given over here. As you, if you are interested in learning all the license and everything, you can read all this. And over here we are having some kind of mathematical denotions for all these simply kind of words. Okay, so lemmatizing will surely what it will do is it will kind of skip all the words which are giving same kind of meanings, and it will convert it into a single word. For example, we say that lengths, we say that running, runs, all those. So it will convert those all convey the same meaning, right? So it will take a single root word and it will truncate all the other similar kind of words. So that is the meaning of lemmatizing. So we'll define a function known as lemmatizing. So we'll say stemmed sentence is equals to an empty string. So for every word in this sentence, we are applying the lemmatizing function, that is lemma.lemmatize of word, right? And then we are adding to this stemmed sentence. And in order to make the sentence look good, so we are using this stem sentence plus equals to white space, so that the sentence is properly organized. And if there are any kind of extra spaces which are left, we will be removing it with the help of the strip function, and then we'll be returning this stem sentence. So same as before, we'll be applying a lambda function to this so that it's inline for loop. So we'll be using books of summary dot apply. So for this lambda x means for every summary in books of summary, apply lemmatizing of x. As simple as that. So how to go forward with lambda functions is lambda x for every summary in books of summary, apply this function, right? So if we just execute this, this will execute it. This will take a little bit time because this NLTK WordNet is a very big file, and this function will also take time because there are many summary sentences which we are passing. So yeah, it's already done. Now the next thing after lemmatizing is we have to stem the sentences. So for stemming, we will be importing a library known as Porter Stemmer, so which is present in nltk.stem. Then we will set a object of it like stemmer is equals to Porter Stemmer, and then we'll define a function. Defining functions are very important because it will directly do the task for us. Just we need to use the apply function over here, as we are doing in so many cases above as well, right? So in stemming, what we'll do is we'll define a function named as stemming, which will take in parameter this sentence. Now this sentence will be of this kind. Okay, the sentence will be of this kind. So we have to split the sentences. So split the sentence into words so that it can be stemmed. So what we are doing is we are saying stemmed sentence is an empty string. For word in stem sentence dot split, for every word you apply stemming algorithm, and then after that algorithm is applied, the result will be stored in the stem. Then you add that into this stemmed sentence empty string, and then in order to make strings look prettified, you add a space over there. So stemmed sentence plus equals to space, right? After all this, what we need to do is we need to strip it if there are any kind of white spaces which are left. Once all this is done, we will be returning the stemmed sentence. So this function will return all the this function will remove all the stemming, and this function will perform the stemming preprocessing, and then it will return the stemmed sentence. Now if you look at so this is the lambda function which is working behind the scenes, and then books of summary.ilocf1 if I do, you can see over here one very important thing. After the stemming, how the sentence will look like. After the stemming, how the sentence will look like. So it is working. It will take a little bit time, and once it is done, then we can display it. So it will take little bit time because stemming is little bit heavy at the back end. Because for example, I'll showcase how the things will work. For example, we are having this enable. So this enable 2 or 3 characters will be removed from back, and U and AB will be showed. For example, we have remember. So E and R will be removed from the back, and the other part will be shown. So here you can see this enable is there. So it just removes the last E, and then only the first top 5 characters are being kept. Over here we were looking at the bus, so it removed the last character, that is S, and bus was there. In some situations it will not remove, but in some situations it will remove. So this stemming algorithm is the Porter stemmer, which is used behind the scenes. So this was all about lemmatizing and stemming. In the next video we'll look at further suggestions and further pre-processing tasks and model building tasks. Thank you.